Our learning target for today is I can convert improper fractions to mixed numbers and mixed numbers to improper fractions. Open up your math book to page 56 and follow along. So let's first talk about what a mixed number is. A mixed number is the sum of a whole number and a proper fraction. I can demonstrate that with my fraction strip here. I have one whole, and I'm going to add it to a 1/4 piece, another 1/4 piece, and another 1/4 piece. And when I add those together, when I add the fourth pieces together, I have 3/4, and I still have this one whole. So my mixed number, it's just a mixture of a whole number, which is one whole, and 3/4, the proper fraction of 3/4. So my fraction strip here shows 1 3/4. I can also show that in this diagram, where I have 2 out of 2 pieces and I've shaded both pieces. So really I have 2 out of 2, or one whole piece. Same with this second one. I have 2 out of 2, or one whole piece. But in this last one, the fraction that is shaded is only 1/2. So I can show this as a mixed number. It's the sum of whole numbers and fractions, or a proper fraction, and I get 2 and 1/2. I have 2 whole pieces and then 1/2 of another one. Let's do another example showing the circles. These circles are cut into fourths. So for this circle, I have 4/4. I have 4/4 that are shaded for this circle. 4 of the 4 are shaded for this circle, and 1 of the 4th is shaded for this circle. So I have 3 wholes and 1/4. Simply put, we just have a mixture of a whole number and a fraction, and that's why it's called a mixed number. It's mixed because we have a mixture of a whole number and a fraction. Another way to look at a mixed number is by looking at it as an improper fraction. In my diagram that I had previously, we made a mixed number out of these diagrams. We have 3 wholes and 1/4 of the other circle. So I had a mixed number of 3 and 1/4. But I can also write this as an improper fraction. So in other words, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13 shaded pieces of these fourths. So I have 13 out of 4 pieces in this diagram that are shaded. That is an improper fraction because an improper fraction is a fraction with a numerator greater than the denominator. Both of these fractions mean the same thing. And we're going to talk about how to convert when you're just given an improper fraction like 9/2. How do we convert that to a mixed number? So let's look at this example here. In this example, I have 2 and 1/4 pieces that are shaded. 2 wholes here, 1, 2, and 1 out of the 4th that is shaded. But I want to also write that as an improper fraction. I can do that. I have 1, 2, 3, 4, 5, 6, 7, 8, and 9 of the 4ths shaded. 2 and 1/4 and 9/4 are the same thing. I don't want to have to draw pictures every time I want to convert an improper fraction to a mixed number or a mixed number to an improper fraction, so we can do it mathematically. If we remember in class, we talked about this fraction bar being the same as division. So in other words, I have 9 divided by 4. And the way I can write that is 9 divided by 4, going back to our division. So I can ask myself, how many 4s do I need in order to get close to 9? I need about 2 of them. So 4 times 2 is 8. I subtract, remembering our long division steps, and I have nothing else to bring down. Now, we learned for decimals we can add that 0, but I really don't want to add the 0 because I'm talking about fractions now. I'm not talking about decimals. So my remainder becomes my numerator and my 4 becomes my denominator. So I end up with 2 1/4 left over. Well, if you look, that's exactly what we had before. So let's take an example, 8 out of 3. That's an improper fraction, and I want to change it to a mixed number. Very, very easy. Remember, this fraction bar means that I divide. So I can write this as 8 divided by 3. And then I can use my long division, 8 divided by 3. So let's do that. 3 times what will give me a number close to 8, and that's 2. 3 times 2 is 6. I subtract, and I have 2 left over. Now, I don't want to put in my decimal. I want to keep it as a fraction. I have 2 and 2 out of the 3 left over. So my mixed number is going to be 2 2/3. It's the same as 8/3. Let's do another example. I have 7 halves. 7 divided by 2 is the same as 7 divided by 2. 2 times what will give me something close to 7? That's 3. I subtract. I have 1 out of the 2 left over. So 3 1/2 is the same as 7 halves. I don't want to always, though, have to do this long division. How can I simplify and think about this easier so I don't always have to do long division? So let's take 9/4. And I know this is the same as 9 divided by 4. Without having to do long division and doing it easier, I can ask myself, how many 4s do I need to pull out of 9? I need 2 whole 4s to take out of 9, because 4 times 2 is 8. And then I have to figure out, after I pull those 2 4s out, how much do I have left over? Well, I have 1. So 9 minus 8 is 1. I have 1 out of the 4 left over. So I can convert this without having to do long division every single time, just by thinking about how many of the denominator do I need to pull out of the numerator, and then whatever I have left over goes over my denominator. So let's do another example. I have 13/3, and I want to change that to a mixed number. I'm going to ask myself, how many 3s can I pull out of 13? In other words, 3 times what will give me a number close to 13, and that is 4. 3 times 4 is 12. 13 minus 12 is just 1, and I just put that over the denominator. So 13/3 is the same as 4 1/3. Let's do another one. How about 15/7? I'm going to ask myself, how many 7s? 7 times what will give me a number close to 15? 7 times 2. 7 times 2 is 14, and 15 minus 14 is 1. So I have 2, and I put that over the denominator, so 2 1/7 is the same as 15/7. Okay, so in this example, I had 15/7 and I turned it into a mixed number, 2 1/7. But what if I want to go back? What if I want to take 2 1/7, and that's what I'm given, and I ask you to write that as an improper fraction? Mathematically, I can do this very easily. All I have to do is take my denominator and multiply it by my whole number. So I'll have 2 times 7, and then I'm going to add my numerator. So I get 2 times 7 is 14, plus 1 is 15, and I'm just going to write that all over 7. And you can see I got the same number back as I did before. I have 15/7. Let's try another example. I have 11/3, and I'm going to change this to a mixed number. So how many 3s can I pull out of 11? I can pull 3. 3 times 3 is 9, and 11 minus 9 is 2. So I have 3 2/3 is the same as 11/3. But what if I'm just given 3 2/3 and I want to convert that to an improper fraction? All I do is I multiply 3 times 3, that gives me 9. So I'm multiplying 3 times 3, and then I add the 2. 9 plus 2 is 11, and I just put that all over my denominator, which is 11/3. And I get the same answer back. Let's do another example. I have 16/6, and I want to convert that to a mixed number. So all I do, 6 times 2 is 12, 6 times 3 is 18, so I know that I can pull 2 6s out of 16 with 4 out of the 6 left over. 2 times 6 is 12, and 16 minus 12 gives me 4 out of the 6. I just put that over the denominator left over. But I have 4/6 here, and 4/6 can be reduced even more. So I have 2 wholes and 4/6, and I can reduce the 4/6 to simplify it a little bit. So I can divide both the top and the bottom by 2 over 2. So I end up with 2 2/3. So 2 2/3 is my answer. You always have to simplify. So let's take that 2 2/3 and let's go ahead and change it into an improper fraction. So I have 2 times 3, I multiply, which is 6, and then I'm going to add the 2. So 2 times 3 is 6, plus 2 is 8, and then I get 8 over 3. Well, that's not what we originally had. We didn't have 8 over 3, but I can see that 16 over 6 can be reduced. It can be simplified. And if I divide both the top and the bottom by 2 over 2, then I get 8. 6 divided by 2 is 3. And there is my answer. So 8/3 is the same as 16 over 6, and it's also the same as 2 2/3. Okay, gang, now it's your turn to practice a little bit. So go to your book, page 59 in your book, under Check Your Understanding, do number 8, A, B, and C, and do number 9, D, E, and F. Make sure you have 6 problems to turn in on your whisk form. See you later.